elevated and depressed freezing point will depress nothing but decreases. So that's about the all four colligative properties. So in this session, I am going to discuss the last topic of the solution chapter. So that is abnormal molar mass. Abnormal molar mass. So what is the meaning of abnormal molar mass and why the abnormal molar mass of the solute takes place? So, and what is the factor that is introduced to modify the equations of colligative properties? All those are discussed in this session. So first, I am going to take a simple solute particle. So let me take A is solute particle in the solution. So it is having the molar mass. So the A having the molar mass, let me take 30 gram per mole, just for simple explanation. So now assume that if the particle, solute particle in the solution, if it is undergo association, they combines together. So one more thing is assume that it may be undergo association or dissociation. So after association, nothing but these particles are combined together to form one particle. For example, A combines together to form one particle. Or so again, after dissociation, nothing but A particle, the solute particle, which may undergo dissociation, let me take that, use the B plus C. So here what happens here? So due to association, two molecules or two particles are combined together form a single particle. So and again, so when the particle undergo dissociation, that gives the two more particles, that is B plus C. So here, what is the molecular molar mass of this particle after dissociation? This is acts as one particle now. After association, this is acts as one particle, and each particle before association, 30 gram per mole is the molar mass. After association, what happens? It may approximately 60 gram per mole. Approximately 60 gram per mole is the molar mass of this particle, solute particle after association. So let me take after dissociation. So the B, the total molar mass is before dissociation, that is 30 gram per mole. After dissociation, let me take, this is having the 20 gram per mole and this is having approximately 10 gram per mole. So here each particle molar mass is observed. So in this case, each particle molar mass is lesser compared to the normal molar mass. That is because of dissociation. So after association, whatever you get the molar mass, that molar mass is higher than that of the normal molar mass. So therefore, so these molar masses, what you get after dissociation or association of solute particles or dissociation of solute particles, adar mukantra molar mass enagta ide either ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ ಇಲ್ಲ ಕಡಿಮೆ ಆಗ್ತಾ ಇದೆ. So due to association molar mass increase ಆಗ್ತಾ ಇದೆ. So due to dissociation molar mass enagta ide normal molar mass ಗಿಂತ ಕಡಿಮೆ ಆಗ್ತಾ ಇದೆ. So therefore these molar masses are considered as normal molar masses ಅಂತ ಹೇಳ್ತೀವಿ. Okay, so then what is the meaning of normal molar mass? So normal molar mass nothing but molar mass which is either lower or higher than normal molar mass, higher than normal value or normal molar mass. So that is called as abnormal molar mass. That is molar mass which is either lower or higher than normal value or the normal molar mass. That is called as abnormal molar mass. Why the abnormal molar mass will take place? So abnormal molar mass is mainly due to two reasons. Abnormal molar mass is because of two reasons. One is due to association of solute particles. And one more is dissociation of solute particles. A very important thing. So why the abnormal molar mass will occur? Because of the association of solute particles, already explained with the example, and dissociation of solute particles, again it is explained with the example. So here normal molar mass is 30 gram per mole before association or dissociation. After association of the solute particles, what happens? Each particle combines together to form a single particle. So what happens here? 60 gram per mole approximately, which is higher than that of the normal value. So therefore, this is the abnormal molar mass. Again, so after dissociation, we get the two particles. A can divide into dissociate into two particles. That is, each one has 20 gram per mole or less 10 gram per mole. Just for explanation, instead of 20 or 10 gram per mole, and each particle in molar mass that should be less than 20 is less than that of the 30. 10 is less than that of the 30. So therefore, again, we are taken as a abnormal molar mass. Totally, the molar mass which is higher, which is either lower or higher than that of the normal value, that is called as normal molar mass. Why the abnormal molar mass is occur? Because of association of solute particles or dissociation of solute particles. Now let me explain one by one. So association of solute particles. Association of solute particles. At the same time, dissociation of solute particles. So before that, so I want to make you recall some important terms. That is, in the starting of this chapter, I already told colligative properties are mainly depends on number of particles. Mainly depends on number of particles. All the colligative properties, we know already explained, the colligative properties are those properties which are mainly depends on number of solute particles, but not on the nature of solute particles. So please remember this, colligative properties directly proportional to number of solute particles, but not on the nature of solute particles. And one more thing we have to remember. So I have explained all the colligative properties. So you remember the equations of each colligative property. So remember, so that is P naught minus P divided by P naught is equal to, so N2 divided by N1 plus N2. So then the simplification mark P naught minus P divided by P naught is equal to N2 divided by N1 because we can get the dilute solution. In the dilute solution, N2 is lesser compared to N1. So again, N2 is equal to N1, that is equal to mass divided by molar mass of the solute into the solubility dividing. N1 is the number of moles of solvent, that is mass of solvent divided by molar mass of solvent. But the reverse of molar mass of solvent divided by mass of solvent. So P naught minus P over P naught is called as RLVP. So in this RLVP, we observe so this is the molar mass of solute. Therefore, RLVP, relative varying of vapor pressure, is inversely proportional to molar mass of solute. Again, let me take the osmotic pressure. So osmotic pressure Y is equal to W2 RT into 1000 whole divided by M2 into B in ml. Just remember this formula. Again, in this case, Y is inversely proportional to molar mass of solute. So that is osmotic pressure inversely proportional to molar mass of solute. And again, one more thing you have to remember. So that is, so delta TB is called as elevation of boiling point of solvent. So that is equal to, so elevation of boiling point of solvent again, Kb into W2 into 1000 whole divided by M2 into W1 in constant. Again, elevation of boiling point of solvent, that is delta Tb, is inversely proportional to molar mass of solute. Inversely proportional to molar mass of solute. Again, one more colligative property, that is delta Tf, that is called as depression of freezing point of solvent, that is written as Kf into W2 into 1000 whole divided by M2 into W1 in constant. Again, that is proportional to molar mass of solute. So here, so in all the cases you can observe. So remember all the colligative properties, that is RLVP, relative varying of vapor pressure, and osmotic pressure point, delta Tb elevation of boiling point, delta Tf depression of freezing point. Remember all the colligative properties. So all the colligative properties are inversely proportional to molar mass of solute. So that you have to recall. So colligative property, all the colligative properties are inversely proportional to molar mass of solute. And also one more thing you have to remember. So that is colligative properties mainly depends on number of particles. These are very important while explaining the association and dissociation of solute particles. Now I will take our first one, association of solute particles. Association of solute particles. So let me take a simple example. So in a beaker, so I am going to a solution. The solution consists of particles. So A, that is the particle, solute particle A. So let me assume that there are 4 particles before association. So now after association, what happens? After association, two molecules or two particles are combined together, resulting in the formation of one particle. So here two particles are combined together to form a one particle, that is called as association. So now how many particles before association? So this is after association. After association. So how many particles are there? Are four particles after before association. After association, how many particles are there? Two particles are there. So remember, so during association, what happens? Number of solute particles will be decreases. Before association, how many particles are there? In the example, 4 particles. After association, what happens? There are 2 particles. This particle is considered as 1 particle. This is a 1 particle. So 2 particles are there. So therefore, during association, what happens? Number of particles, number of solute particles in item, that will be decreases. So, and what happens to colligative property? So, please remember, very simple concept. Colligative property directly proportional to number of particles. Already we said colligative properties are mainly depends on the number of solute particles. So, due to association, number of solute particles decreases, and then what happens to colligative property? Colligative properties are also decreases. What are those colligative properties? That is RLVP. Osmotic pressure, elevation of boiling point, depression of freezing point. All those qualitative properties are decreases because there is a decreasing in number of particles due to association of solute particles. And one more thing, what happens to the molar mass of the solute particle? So before after association molar mass ಏನಾಗುತ್ತೆ ಅಂತ observe ಮಾಡಿ. So ಇಲ್ಲಿ colligative property as ಏನಾಗಿದೆ decrease ಆಗಿದೆ. And one more thing you have to remember, colligative property inversely proportional to molar mass of solute. That's why I told you it's very very important. Colligative property inversely proportional to molar mass of solute. You can remember all these formulas. So formulas in the observe ಮಾಡಿ. All the colligative properties are inversely proportional to molar mass of solute. So therefore, since because of the association, the number of solute particles decreases, hence the colligative properties also decreases. Since the colligative properties decreases, what happens to the molar mass of solute? Molar mass of solute is increases. Molar mass of solute is increases. These are the very very important point. So for the explanation in the case of association. So observe ಮಾಡಿ. Let me take A is the particle. Before the association, let me take that is the molar mass is 30. So after association, what happens? Two A particles combines together to form a one solute particle. Then one solute particle after association, the molar mass becomes 60. So approximately 16 daga. So after association, what happens to the molar mass? That will be increases. 30 to after association is to 60 ಆಯಿತು. Therefore molar mass ಏನಾಗುತ್ತೆ? ಜಾಸ್ತಿ ಆಗುತ್ತೆ. Since the number of particles decreases, all the colligative properties also decreases. And one more thing, so number of particles decrease ಆದಂಗೆ colligative property ಏನಾಗಬೇಕು? Decrease ಆಗಬೇಕು because of this proportionality. All the colligative properties are mainly depends on number of solute particles. Let me take a simple example. That's about the association of solute particles. So a simple example ತಗೊಂಡ್ರಿ. So that is ethanoic acid in benzene. Ethanoic acid in benzene. So this is the best example for association of the solute particle, which is a solute here. So ethanoic acid is a solute. Nothing but ethanoic acid is nothing but acetic acid. So that is benzene is acts as a solvent. So in the benzene, ethanoic acid undergo association. Especially the ethanoic acid in benzene undergo dimerization. That is undergo dimerization. That is undergo dimerization. So how the dimerization will take place? Dimerization through hydrogen bonding. Through hydrogen bonding. So let me take ethanoic acid acts as solute particle here. So therefore what happens? So let me take the ethanoic acid here. CH3, C double bond OH. This is the ethanoic acid. So let me take another ethanoic acid molecule, that is CH3, C OH double bond O. CH3, C double bond OH and CH3, C double bond OH. So here two molecules which are undergo association through which bonding? Hydrogen bonding. So here there is oxygen. Here there is hydrogen which is electronic, it is attached to electronegative atom. Now there is a formation of hydrogen bond. That is an intermolecular hydrogen bonding. That is hydrogen bonding takes place between the two molecules. And again one more hydrogen bonding takes place. That is hydrogen that is attached to oxygen. That is also involved in the hydrogen bonding with the oxygen of the other molecule. So you observe money. Before association, there are two particles. After association, what happens? This is acts as a one single particle. After association, so that is after association nothing but that acts as a one particle. So even if the acetic acid ke molar mass count mari, that is about 60 gram per mole. Let me calculate. So calculate what 60 gram per mole barutte. After association, this is complete become a one particle. So the number of particles 2 ittu ankondaga. So after association enayitu one particle aitu. So our one particle aitu andre one molecule of acetic acid is 60 gram per mole is the molar mass. After association, two molecules combine agide. So therefore, what happens? 120 gram per mole is the molar mass after association. But after association, molar mass just agate. So matlab colligative properties enagate decrease agate. Yakandre two particles ittu acetic acid before association. After association, this has become one particle. So that is the best example for association of solute particle. That is ethanoic acid in benzene undergo dimerization. Dimerization nothing but two acetic acid particles or molecules combines together to form a single molecule. So that is the one of the dimerization product. Okay, this is the dimerized product. So dimerization agide through hydrogen bonding. Dimer antandaga two molecules are combined anta ಹೇಳ್ತೀವಿ. So ಇಲ್ಲಿ two acetic acid molecules are joined together through the hydrogen bond. So that is undergo association. So therefore, the ethanoic acid in benzene is a best example for association of solute particles. So that's about the concept of association of solute particles. So let me take another important concept, that is dissociation of solute particles. That is dissociation of solute particles. So again let me take solute particle A. The two particles are there. So after dissociation, when it is solute particle undergo dissociation, so that would take A solute particle undergo dissociation, that gives B plus C. One A particle ಏನಾಗ್ತದೆ D and C ಅಂತ ಮಾಡ್ತಿದೆ, ಇನ್ನೊಂದು ಅದೇ ರೀತಿ ಆಗುತ್ತೆ, that is B plus C. So here, so before dissociation, how many particles are there? Two particles are there. After association, how many particles? So there are four particles are there. So assume that. So here there are two particles before dissociation. After dissociation, how many particles? Four particles. Therefore, due to dissociation, what happens to the number of solute particles? Number of solute particles, that is increases. Number of solute particles increases. And one more thing you have to remember, that is colligative properties are directly proportional to number of particles. Due to dissociation, number of particles increases. Therefore, all the colligative properties also increases. But one more thing you have to remember, colligative property inversely proportional to molar mass of solute. Therefore, what happens to molar mass of solute? Molar mass of solute, that will be decreases. Again, the colligative property inversely proportional to molar mass. Let me take. So that is A is the particle, solute particle before dissociation. So let me take example, the molar mass is 30. So after dissociation, that is split up into two. That is dissociated into two particles, that is B and C. 100% ಹೇಳ್ತೀವಿ B and C ನಲ್ಲಿ molar mass ಏನಾಗುತ್ತೆ A ಗಿಂತ ಕಡಿಮೆ ಇರಬೇಕು, ಯಾಕಂದ್ರೆ C ಬಂದಿರೋದ್ರಿಂದ. Let me take, that is about 20 gram per mole and C having 10 gram per mole. So that's what happens to molar mass of each particle. So that will be decreases. And what are colligative properties are increases because number of particles increases. So that is the best one of the concept of dissociation of the solute particles. Let me take a simple example. So example is dissociation of the NaCl. So NaCl totally. So when NaCl undergo dissociation, what do you get? Na plus Cl minus. So before dissociation, this is acts as one particle. NaCl is acts as one particle. After dissociation, Na plus acts as a one particle and Cl minus acts as a one particle. Before dissociation, how many particles are there? One particles. After dissociation, so there are two particles, Na plus and Cl minus. So what is the molar mass of NaCl? That is about 58.5 gram per mole. Na23, chlorine atomic mass 35.5, add ಮಾಡ್ಕೊಂಡ್ರೆ will get 58.5 gram per mole. So ಆಮೇಲೆ ಮತ್ತೆ ನೀವು ಡಿವೈಡ್ ಮಾಡಿದಾಗ Na plus is acts as one particle, Cl minus is acts as one particle. So what is the atomic mass? You will not take it as a molar mass because the elemental form of ionic form ಅಲ್ಲಿ. So that is 23 ಆಗುತ್ತೆ. So ಇದು ಎಷ್ಟಾಗುತ್ತೆ? 35.5 ಆಗುತ್ತೆ. So observe ಮಾಡಿ 23 is lesser than 58.5. 35.5 is also lesser than 58.5. So therefore, after dissociation, what do you get the particles? Those solute particles having the lesser molar mass compared to that of the normal molar mass. Therefore, molar mass in other solute particles decrease compared to normal molar mass. So that is about the dissociation of solute particles. So while explaining the dissociation and association, you have to recall this important point, that is colligative property directly proportional to number of solute particles and all the colligative properties inversely proportional to molar mass of solute. So that is about the concept of association and dissociation of solute. So because of these two, association and dissociation, the molar mass will be changes. That molar mass is called as abnormal molar mass. So that's about the concept, and so that is to explain to extent of dissociation and association. And again, the solute particles undergo association and dissociation at the entire. How much amount of dissociation and association will take place? That is to explain the extent of association and dissociation. ಈಗ solute ಎಷ್ಟು ಪಟ್ಟಿಗೆ ಎಷ್ಟು extent ಅಲ್ಲಿ association ಆಗ್ತಾ ಇದೆ ಅಥವಾ ಎಷ್ಟು extent ಅಲ್ಲಿ dissociation ಆಗ್ತದೆ, ಎಷ್ಟು percentage ಆಗ್ತಾ ಇದೆ. So to calculate to explain the extent of dissociation or association of solute particles, to explain the extent of association or dissociation of solute particles, one of the factor was introduced by a scientist, that is Van 't Hoff. One of the factor introduced by a scientist, that is called as, that was Van 't Hoff. So that is the factor is called as Van 't Hoff factor. The factor is called as Van 't Hoff factor, indicated by I. So very, very important for 1 mark ಅಥವಾ competitive exams ಅಲ್ಲಿ. So Van 't Hoff factor used ಅಥವಾ Van 't Hoff factor ಏನಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ? It explains, ಎರಡು ಆಪ್ಷನ್ ಕೊಡ್ತಾರೆ, ಆ ಯಾವ್ದಾದ್ರು ಆಪ್ಷನ್ಸ್ ಕೊಡ್ತಾನೆ, ಅದರಲ್ಲಿ ಒಂದು ಆಪ್ಷನ್ ಏನಿರುತ್ತೆ, it explains the dissociation or association of solute particles. ಎಷ್ಟು ಮಟ್ಟಿಗೆ dissociation ಆಗುತ್ತೆ, how much extent of dissociation and how much extent of association of solute particles takes place. So that is explained by using one of the factor. That factor is introduced by Van 't Hoff. That factor is called as Van 't Hoff factor. For theory, it is a very, very important. Define Van 't Hoff factor and write its application. So ಏನಕ್ಕೆ Van 't Hoff factor ಬೇಕು ಅಂದ್ರೆ, to explain the extent of dissociation or association of solute particles. And what is the meaning of Van 't Hoff factor? So Van 't Hoff factor defined as I is equal to, it's the ratio of normal molar mass, it's the ratio of normal molar mass divided by abnormal molar mass. It is the ratio of normal molar mass to the abnormal molar mass is called as Van 't Hoff factor. ಅಥವಾ ಇದು ಇನ್ನೊಂದು ತರ ಹೇಳ್ಬೋದು. So that is equal to observed colligative property divided by calculated colligative property. So calculated ki ಇನ್ನೊಂದು ನೇಮು experimental ಅಂತ ಹೇಳ್ಬೋದು. So observed colligative properties divided by calculated colligative properties. So that is normal molar mass is inversely proportional to calculated colligative property. Abnormal molar mass, that is observed after dissociation or association, that is observed colligative property. ಯಾಕೆಂದ್ರೆ colligative property inversely proportional to molar mass. So ಇದನ್ನ ಡಿಫೈನ್ ಮಾಡಬಹುದು ಅಥವಾ ಇನ್ನೊಂದು ತರ ಡಿಫೈನ್ ಮಾಡಬಹುದು. That is I is equal to I is equal to total number of moles of solute particles. Total number of moles of solute particles after association or dissociation. After association or dissociation divided by total number of solute particles before association or dissociation. See how it in the observed colligative property. Observed colligative property ಅಂದ್ರೆ ಅದು ಬರೋದು ಯಾವಾಗ ಅಂದ್ರೆ after dissociation or association. ಅದನ್ನ ಹೇಳ್ತಾರೆ. Total number again colligative property mainly depends on number of solute particles. Therefore, observed colligative property is nothing but number of particles or total number of moles of solute particles after association or dissociation. After association and dissociation, we'll get the molar mass. That molar mass is called as observed molar mass or abnormal molar mass. Abnormal molar mass is inversely proportional to observed colligative property. Observed colligative property ಯಾವಾಗ ಬರುತ್ತೆ ಅಥವಾ abnormal mass molar mass ಯಾವಾಗ ಬರುತ್ತೆ ಅಂದ್ರೆ after association or dissociation. And calculated colligative property ಅಥವಾ ನಾರ್ಮಲ್ molar mass. Normal molar mass ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ ಬಿಫೋರ್ ಅಸೋಸಿಯೇಷನ್ ಡಿಸೋಸಿಯೇಷನ್ ಏನ್ ನಿಮಗೆ molar mass ಇರುತ್ತೆ ದಟ್ ಈಸ್ ಇಟ್ಸೆಲ್ಫ್ ನಾರ್ಮಲ್ molar mass ಅಂದ್ರೆ ಅಲ್ಲಿಗೆ ಸೊ calculated colligative property is nothing but total number of moles of solute particles before association or dissociation. So ಈ ಮೂರಲ್ಲಿ ಯಾವ ರೀತಿ ಬೇಕಾದ್ರೂ ಡಿಫೈನ್ ಮಾಡಬಹುದು. Define Vanta factor simply. So I is equal to normal molar mass divided by abnormal molar mass. That is the one of the introduction of the Vanta factor. And why we are going to introduce the Vanta factor? Because to explain the extent of association or dissociation of solute particles. So now let me take that. So Vanta factor is not for association of solute particles. For association of solute particles. So association ಆದಾಗ ನಾನು ಆಗಲೇ ಹೇಳಿದೆ ನಿಮಗೆ ಅಸೋಸಿಯೇಷನ್ ಆದಾಗ ಏನು ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಎ ಅಂತ ಎರಡು ಪಾರ್ಟಿಕಲ್ ಇತ್ತು, ಅಸೋಸಿಯೇಷನ್ ಆದಾಗ ಏನಾಗುತ್ತೆ ದಟ್ ಈಸ್ ಎ ಒಂದು ಪಾರ್ಟಿಕಲ್ ಆಗುತ್ತೆ. ಸೊ ಎಗೆ ಅಬ್ಸರ್ವ್ಡ್ ಮೋಲಾರ್ ಮಾಸ್ ಎಷ್ಟಿದೆ ಅಂತ ಅನ್ಕೋಣ 30 ಅಂತ ಇಟ್ಕೋಣ. ಸೊ ಆಫ್ಟರ್ ಅಸೋಸಿಯೇಷನ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಇಟ್ ಇಸ್ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ 60 ಆಗುತ್ತೆ. ಸೊ ದೇರ್ಫೋರ್ ಅಂದ್ರೆ ಯಾವ ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಆಗುತ್ತೆ ಡ್ಯೂ ಟು ಅಸೋಸಿಯೇಷನ್ abnormal molar mass is higher than that of the normal molar mass. So due to association what happens? Observed abnormal molar mass. Shortcut abnormal molar mass is higher than that of the normal molar mass. Due to association what happens? Observed abnormal molar mass is higher than that of the normal molar mass. Then what happens to Vanta factor? So therefore Vanta factor is equal to normal molar mass divided by abnormal molar mass. ಯಾವ ಜಾಸ್ತಿ ಇದೆ? abnormal molar mass ಜಾಸ್ತಿ ಇದೆ. abnormal molar mass ಎಲ್ಲಿದೆ? ಇಲ್ಲಿ ಡಿನಾಮಿನೇಟರ್ ಇದೆ. ಡಿನಾಮಿನೇಟರ್ ನ್ಯೂಮರೇಟರ್ ಗಿಂತ ಜಾಸ್ತಿ ಇದೆ ಅಂದ್ರೆ ಬರ್ತಕ್ಕಂತ I ವ್ಯಾಲ್ಯೂ ಏನಾಗಿರುತ್ತೆ I is definitely less than 1. This is a very very important. What is the I value for association of solute? That is I is less than 1. So ಮದರ್ ಮಾಡಕ್ಕೆ ಹೋಗ್ಬೇಡಿ. ಯಾವ ರೀತಿ ಆಗುತ್ತೆ normal molar mass divided by abnormal molar mass, that is I. So due to association what happens? Abnormal molar mass ಜಾಸ್ತಿ ಆಗುತ್ತೆ compared to normal molar mass. So therefore abnormal molar mass denominator ಇದೆ, normal molar mass numerator ಇದೆ. Numerator ಗಿಂತ denominator ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ 100% ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ I is less than 1. So this is for association of solute. So one more thing, so that is for dissociation of solute particles. Dissociation of solute particle ತಗೊಂಡಾಗ so let me take a simple example. So A is undergo dissociation that gives B plus C ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. ಸೊ ಆಗ ಇದೊಂದು molar mass ಏನಾಗುತ್ತೆ ಇದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಯಾಕಂದ್ರೆ ಇವೆಲ್ಲ ಡಿಸೋಸಿಯೇಟ್ ಆಗೋದ್ರಿಂದ ಇಲ್ಲಿ ಬರ್ತಕ್ಕಂಥ ಪಾರ್ಟಿಕಲ್ಸ್ molar mass, that is abnormal molar mass is lesser compared to normal molar mass. So that is due to dissociation what happens? Abnormal molar mass is lesser compared to that of normal molar mass. So then abnormal molar mass ಕಡಿಮೆ ಇದೆ. So normal molar mass ಜಾಸ್ತಿ ಇದೆ. So numerator ಜಾಸ್ತಿ ಇದೆ, denominator ಕಡಿಮೆ ಇದೆ. Definitely you will get the I value greater than 1. So that is I is greater than 1. Vanta factor is greater than 1 for dissociation of the solute particles. So one more thing we have to discuss. So if therefore neither association nor dissociation of solute particles, nor dissociation of solute. ಇದಕ್ಕೇನಾಗಿದೆ ನೈದರ್ ಡಿಸೋಸಿಯೇಷನ್ ನಾರ್ ಅಸೋಸಿಯೇಷನ್ ಅಂದ್ರೆ ಡಿಸೋಸಿಯೇಷನ್ ಆಗಲಿಲ್ಲ ಅಥವಾ ಅಸೋಸಿಯೇಷನ್ ಆಗಲಿಲ್ಲ ಅಂತಂದ್ರೆ ಸೊ ನಾರ್ಮಲ್ ಮೋಲಾರ್ ಮಾಸ್ ಎಷ್ಟಿರುತ್ತೋ ಅಬ್ನಾರ್ಮಲ್ ಅಷ್ಟೇ ಇರುತ್ತೆ. ಸೊ ದೇರ್ಫೋರ್ ಐ ವ್ಯಾಲ್ಯೂ ನೋಡಿ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ಡ್ ಅಬ್ನಾರ್ಮಲ್ ಮೋಲಾರ್ ಮಾಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ನಾರ್ಮಲ್ ಮೋಲಾರ್ ಮಾಸ್ because there is no any association or dissociation. ಏನಾದರೂ ಆಗಲಿಲ್ಲ ಈಗ ಡಿಸೋಸಿಯೇಷನ್ ಅಸೋಸಿಯೇಷನ್ ಆಗಲಿಲ್ಲ ಅಂದ್ರೆ ಡೆಫಿನೆಟ್ಲಿ ಮೋಲಾರ್ ಮಾಸ್ ಚೇಂಜ್ ಆಗಿರಲಿಲ್ಲ. ಸೊ ದೇರ್ಫೋರ್ ಅಬ್ನಾರ್ಮಲ್ ಮೋಲಾರ್ ಮಾಸ್ ಇಸ್ ಸೇಮ್ ಆಸ್ ದಟ್ ಆಫ್ ದಿ ನಾರ್ಮಲ್ ಮೋಲಾರ್ ಮಾಸ್. ದೇರ್ಫೋರ್ ಏನಾಗುತ್ತೆ ಐ ಇಸ್ ಈಕ್ವಲ್ ಟು 1 ಆಗುತ್ತೆ. ಯಾಕಂದ್ರೆ ಎರಡು ಸೇಮ್ ಆಗುತ್ತೆ ಡಿವೈಡ್ ಮಾಡಿದಾಗ ಎಷ್ಟು ಬರುತ್ತೆ 1 ಬರುತ್ತೆ. ದಿಸ್ ಇಸ್ ಅ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್. ದಟ್ ಈಸ್ ಫಾರ್ ಎ ಸಲ್ಯೂಟ್ if the Van der factor is less than 1, what is the conclusion drawn from it anta keltane. That is one mark question already kelidare simple exam alli. So if the Van der factor is less than 1, what is the conclusion drawn from it? Less than 1 barta ide andre the conclusion is there is a association of solute particle. Simple one mark question. So again, what is the conclusion drawn if the solute have the I value, that is Van der factor greater than 1, that is the conclusion is there is a dissociation of solute particle. If the I value is equal to 1, what is the conclusion? So there is neither association nor dissociation. Or simply, solute do not undergo any association or association. So that is about the concept of I, that is Van der factor, and how it is related to abnormal molar mass and normal molar mass. So one more simple, ಸ್ವಲ್ಪ applied level questions ಹೋದಾಗ what is the I value for electrolytes? Simple. Electrolytes ಅಂದ್ರೆ ಏನು? So for example, say aqueous NaCl. ಈಗ aqueous NaCl ತಗೊಂಡಾಗ NaCl is dissolved in water, that can be split up into 2 ions, that is Na plus and Cl minus. Electrolyte ಅಂತ ಹೇಳ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ definitely that conduct electricity. So electricity ಯಾಕೆ ಬರುತ್ತೆ? In the case of electrolyte, electricity is mainly due to movement of ions. ಅಲ್ಲಿಗೆ ions ಬರಬೇಕು ಅಂದ್ರೆ ಈ ಒಂದು solute particle ಏನಾಗಬೇಕು ಅಂದ್ರೆ ಡಿಸೋಸಿಯೇಟ್ ಆಗಬೇಕು. So dissociate ಆಗ್ತಾ ಇದೆ ಅಂದಾಗ ನೀವು ಈಸಿಯಾಗಿ ಹೇಳ್ಬೋದು. So for the dissociation what is the I value? That is greater than 1. So ಅಂದ್ರೆ ನಿಮಗೆ ಡಿಸೋಸಿಯೇಷನ್ ಅಂತ ಕೇಳೋ ಬದಲಿಗೆ ಸೊ ನಿಮ್ಗೆ ಕೇಳ್ತಾನೆ what is the Van der factor value for electrolytes ಅಂತ ಕೇಳ್ತಾನೆ. It may be weak electrolyte or it may be strong electrolyte. Totally it undergo dissociation. It may be weak or strong. Weak ಆದ್ರೆ partial dissociation ಆಗುತ್ತೆ, strong ಆದ್ರೆ complete dissociation ಆಗುತ್ತೆ. Totally dissociation ಆಗೋದ್ರಿಂದ 100% ನಿಮಗೆ ಏನಾಗುತ್ತೆ particles ಜಾಸ್ತಿ ಆಗುತ್ತೆ. So therefore ಅಲ್ಲಿ normal molar mass observed molar mass ಅಬ್ಸರ್ವ್ ಮಾಡಿ. So normal molar mass abnormal molar mass ಅಲ್ಲಿ abnormal molar mass is less than that of the normal molar mass. Therefore due to association I is greater than 1. So therefore I value is greater than 1 for any electrolyte. ನೀವು ಯಾವುದೇ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ತಗೊಳ್ಳಿ ಐ ಬೆಲೆ ಏನಾಗಿರುತ್ತೆ ಗ್ರೇಟರ್ ದನ್ 1 ಆಗುತ್ತೆ ಬಿಕಾಸ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ಸ್ ಅಂಡರ್ಗೋ ಡಿಸೋಸಿಯೇಷನ್. ಅಂಡ್ ವಾಟ್ ಈಸ್ ದ ಐ ವ್ಯಾಲ್ಯೂ ಫಾರ್ ಎಥನೋಯಿಕ್ ಆಸಿಡ್ ಇನ್ ಬೆನ್ಸಿನ್? ಸೊ ದಿಸ್ ಸಿಂಪಲ್ ಕ್ವೆಶ್ಚನ್. ಎಥನೋಯಿಕ್ ಆಸಿಡ್ ಇನ್ ಬೆನ್ಸಿನ್ ಆಲ್ರೆಡಿ ಎಕ್ಸ್ಪ್ಲೈನ್. ಎಥನೋಯಿಕ್ ಆಸಿಡ್ ಇನ್ ಬೆನ್ಸಿನ್ ಅಂಡರ್ಗೋ ಡೈಮರೈಸೇಷನ್. ಎಥನೋಯಿಕ್ ಆಸಿಡ್ ಇನ್ ಬೆನ್ಸಿನ್ ಅಂಡರ್ಗೋ ಡೈಮರೈಸೇಷನ್. ಸೊ ಐ ವ್ಯಾಲ್ಯೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀನಿ. ಸೊ ವಾಟ್ ಈಸ್ ಎಥನೋಯಿಕ್ ಆಸಿಡ್? ಎಥನೋಯಿಕ್ ಆಸಿಡ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಅಸಿಟಿಕ್ ಆಸಿಡ್. So acidic acid ಗೆ molar mass calculate ಮಾಡ್ಕೊಳ್ಳಿ. ಕಾರ್ಬನ್ 2 ಇದೆ, so 2 into 12 that is equal to 24. ಆಕ್ಸಿಜನ್ 2 ಇದೆ, 2 into 16 atomic mass that is equal to 32. ಹೈಡ್ರೋಜನ್ 4 ಇದೆ, 1 that is 4 into atomic mass is 1 that is equal to 4. Total you can calculate that is 60 gram per mole is the molar mass of the acetic acid, one acetic acid particle before association, nothing but before dimerization. That you have to remember, ethanoic acid or acetic acid in benzene undergo dimerization. ಈಗ ನಿಮಗೆ ನಾರ್ಮಲ್ molar mass before association or before dimerization ಎಷ್ಟಿದೆ 60 gram per mole ಇದೆ. That's the normal molar mass. After association, nothing but dimerization, two acetic acid molecules are combined together through hydrogen bonding, nothing but undergo dimerization through hydrogen bonding. ಆವಾಗ ಆ ಎರಡು ಪಾರ್ಟಿಕಲ್ ಸೇರ್ಕೊಂಡು ಒಂದು ಪಾರ್ಟಿಕಲ್ ಆಗುತ್ತೆ. ಅಲ್ಲಿಗೆ ಟೋಟಲಿ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ ಎಷ್ಟಾಗುತ್ತೆ ಅಬ್ನಾರ್ಮಲ್ molar mass that is become 120. So therefore 61s 62s that is off, that is 0.25 is the Van der factor for the ethanoic acid in benzene. It's a very important for 1 mark. What is the value of Van der factor for acetic acid or ethanoic acid in benzene? That you have to remember, ethanoic acid in benzene undergo association, that is especially undergo dimerization through which bond hydrogen bond. So therefore I value ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಇಲ್ಲಿ 60 by 120, that value is 0.25 ಅಥವಾ off. That is the answer for Van der factor for ethanoic acid in benzene. That is one of the best examples for association. Dissociation, number of examples in there. You can take any electrolyte that is about dissociation. So neither association, neither dissociation, the examples in here. Let me take a glucose, other is sucrose, nothing but saccharides, monosaccharides, disaccharides, and also one more thing is urea. So all these, some other examples also there. So let me take the glucose, sucrose, urea. They do not undergo any association or dissociation. So association agodilla or dissociation agodilla. Since they do not undergo any association or dissociation, what happens? I value is equal to 1 because abnormal molar mass is equal to normal molar mass. Hence, this is because of there is no association or dissociation of these solid particles. So it is a very, very important for electrolytes. There is a dissociation. I is greater than 1. If it is I is greater than 1, what is the conclusion? That is the dissociation of solute. If the I is less than 1, what is the conclusion? There is association of solute. What is the conclusion if the I is equal to 1? There is no dissociation or association. Nothing but neither association or nor dissociation. So that's about the concept of Van 't Hoff factor and how it is related to abnormal molar mass or normal molar mass, and what are the I value for different types of substances, that is for electrolytes, ethanoic acid in benzene, for urea, glucose, sucrose, etc. So that is about the Van 't Hoff factor, abnormal molar mass. That's about your chapter, that is solutions. So istu ನಿಮ್ಮ solution chapter ಇರೋದು, and related to this abnormal molar mass and Van 't Hoff factor, there is one important extra information that is very, very useful to your competitive exams, especially for problems. So let me discuss that one. That is the relationship between before that, one more thing. So because of Van 't Hoff factor, the colligative property equations are modified by Van 't Hoff factor. So colligative property equations are they are modified by the Van 't Hoff factor. The Van 't Hoff factor is taken as I. So modified equations. So colligative property equations go to that. So ಅಲ್ಲಿ colligative properties ಅನ್ನೋದು mainly depends on number of solute ಕಡಿಮೆ ಆಗುತ್ತಾ ಜಾಸ್ತಿ ಆಗುತ್ತಾ ಅನ್ನೋದು mainly depend ಆಗೋದು association and dissociation. Association and dissociation is explained by Van 't Hoff factor. Just think the relationship. ನೋಡಿ ಯಾವ relationship ಬರ್ತಾ ಇದೆ. Colligative property depends on number of solute particles. Number of particles ಕಡಿಮೆ ಆಗ್ತಾ ಇದೆಯಾ ಅಥವಾ ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆಯಾ, that is mainly depends on association or dissociation. The extent of association and dissociation is explained by Van 't Hoff factor. So that the Van 't Hoff factor, by increasing the Van 't Hoff factor, there are some modified equations for colligative properties. What are those modified equations? The modified equations are P naught minus P divided by P naught is equal to X2 delta. That is the number of mole fraction of solute. So any modified material just by multiplying with I. That is the Van 't Hoff factor. That is a modified equation. So again, this is for RLB. So again, for atmospheric pressure, pi is equal to CRT, where C is the concentration, R is the constant, T is the temperature. Modified equation is I into CRT. That is pi is equal to I into CRT. Matte C ಏನು ಮಾಡ್ತೀವಿ molarity W2 into 1000 divided by M2 into V in ml ಅನ್ನು ಮಾಡ್ಕೊಳ್ತೀವಿ. Again, for elevation of boiling point of solvent, that is delta Tp is equal to Kp into molarity, that is small f, and what is the modified equation? Multiplied by I. That is a modified equation. So again, one more, that is delta Tf is equal to, so Kf into M, and a modified equation by increasing the factor, Van 't Hoff factor. So all these colligative properties are modified by increasing the factor. That factor is called as Van 't Hoff factor. Just we are going to multiply that Van 't Hoff factor with the term x to CRT, Kb into M, Kf into M. ಏನು ಮಾಡಬೇಕು? Just I ನ multiply ಮಾಡ್ಕೋಬೇಕಾಗುತ್ತೆ. This is very, very important for problems. ಕೆಲವೊಂದ್ಸಲಿ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅಲ್ಲಿ I value ಇಲ್ಲದನೇ ಪ್ರಾಬ್ಲಮ್ಸ್ ಕೇಳ್ತಾರೆ. ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಅಲ್ಲಿ ಮಾತ್ರ ಕೆಲವೊಂದ್ಸಲಿ I value ತಗೊಂಡು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. This is very, very important. These are the modified equations of all the colligative properties that are modified by using the factor. The factor is called as Van 't Hoff factor. That's also included in your syllabus. And one more important extra information for competitive exams, especially for NEET and also for CET and also for JEE. So it's important relationship between degree of dissociation. Relationship between degree of dissociation or association and Van der factor. And for Van der factor, this is very important. What is the relationship between degree of dissociation and degree of dissociation and Van der factor? First, I am going to take degree of dissociation, that is alpha D. Degree of dissociation, that is equal to I minus 1 divided by n minus 1. This is a very important equation. So where I is the Van der factor and n is the number of particle after dissociation. After dissociation admele ಎಷ್ಟು particles ಬರ್ತಿದೆ, so that is n value. This is the relationship between degree of dissociation and Van der factor. So again, so there is a relationship between degree of association alpha a ಅಂತ ತಗೊಂತಾ ಇದೀನಿ, that is equal to I minus 1 divided by 1 by n minus 1. So why we are taken the 1 by n here and here is n. So what happens, the number of particles after association? After association, number of particles decreases. So that is, what is the n value here? This is the n is the number of particles involved in the association. What is n here? N is the number of particles after dissociation. Here n is the number of particles before association. H particles into association. 2 particles association ಆಗ್ತಿದೆ ಅಂದ್ರೆ 1 by 2 ಅಂತ ಆಗುತ್ತೆ. 3 particle association ಆಗ್ತಿದೆ 1 by 3. 4 particle ಆಗ್ತಿದೆ 1 by 4. ಅದನ್ನ ಎಂತ ಕರಿತೀವಿ? Dimerization, or is previously 1 by 2. ಅಲ್ಲಿ 1 divided by number of particles associated ಆಗ್ತಾ ಇರೋದು 2 particles, that is dimerization. So trimerization, 3 particles associated ಆಗ್ತಾ ಇದೆ 1 by 3. So tetramerization 1 by 4 ಆಗುತ್ತೆ. So that is n is the number of solute particles involved in the association. Here the n is number of particles formed after dissociation. After dissociation, that is the very important relationship between degree of dissociation and Van der factor, degree of association and Van der factor. In the last year CET idra mere one question kelitu, so adana elevation of boiling point anta heli adakke link ಮಾಡಿ, so I value calculate ಮಾಡಿಕೊಂಡು ನೀವು elevation of boiling point ಕಂಡುಹಿಡಿಯಬೇಕಾಗಿತ್ತು. So last year CET paper ಅಲ್ಲಿ ಇದರ ಬೇಸ್ ಮೇಲೆ ಡಿಗ್ರಿ ಆಫ್ ಅಸೋಸಿಯೇಷನ್ ಕೊಟ್ಟಿದ್ದಾನೆ, ಅದನ್ನು ಟೆಟ್ರಾಮರೈಸೇಷನ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾನೆ. ಅವಾಗ ನೀವು ಫಸ್ಟ್ ವ್ಯಾನ್ der ಫ್ಯಾಕ್ಟರ್ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಇಲ್ಲಿ ಮತ್ತೆ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡಿ ನಾವು ಎಲಿವೇಷನ್ ಆಫ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಅಥವಾ ಮೋಲಾರ್ ಮಾಸ್ ನ ಕಂಡುಹಿಡಿಯಬೇಕಾಗಿತ್ತು. ದಟ್ ಇಸ್ ಇನ್ ದ ಲಾಸ್ಟ್ ಇಯರ್ ಸಿಇಟಿ ಪೇಪರ್ ಇದೆ, ಚೆಕ್ ಮಾಡಿಬೇಕಾದ್ರೆ. ಸೊ ಇಲ್ಲಿ ನಿಮಗೆ ಇನ್ನೊಂದು ಹೇಳು, ಇಫ್ ದ ಸಲ್ಯೂಟ್ ಅಂಡರ್ಗೋ 100% dissociation. If the solute undergo 100% dissociation, what happens to I value? So ಈಗ alpha d ಏನು ಬರ್ತೀವಿ, alpha d is equal to I minus 1 divided by n minus 1. What is the degree of dissociation? That is 100%. ಅಂದ್ರೆ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಎಷ್ಟಿದೆ? ಪರ್ಸೆಂಟ್ ಅಂದ್ರೆ 100 ಇದೆ. ಅದರಲ್ಲಿ ಎಷ್ಟು ಡಿಸೋಸಿಯೇಟ್ ಆಗಿದೆ? 100 ಡಿಸೋಸಿಯೇಟ್ ಆಗಿದೆ. ಸೊ therefore 100% ಅಂದಾಗ degree of dissociation is equal to 1. So degree of dissociation meaning ಏನಂದ್ರೆ number of particles dissociated to the total number of molecules present. ನ್ಯೂಮರೇಟರ್ ಅಲ್ಲಿ ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಎಷ್ಟು ಡಿಸೋಸಿಯೇಟ್ ಆಗಿದೆ ಅಂತ ನೋಡ್ಕೋಬೇಕು. ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಎಷ್ಟಿದೆ, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಡಿಗ್ರಿ ಆಫ್ ಡಿಸೋಸಿಯೇಷನ್. 100% ಡಿಸೋಸಿಯೇಟ್ ಆಗಿದೆ ಅಂದ್ರೆ ಇರ್ತಕ್ಕಂಥ 100 ಮಾಲಿಕ್ಯೂಲ್ ಅಲ್ಲಿ 100 ಮಾಲಿಕ್ಯೂಲ್ ಡಿಸೋಸಿಯೇಟ್ ಆಗಿದೆ ಅಂತ ಅರ್ಥ. ಸೊ therefore alpha d is equal to 1 ಆಗುತ್ತೆ, that is equal to I minus 1 divided by n minus 1. So then what happens, I minus 1 is equal to n minus 1 ಆಗುತ್ತೆ. So ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲಿಕೇಷನ್ ಮಾಡ್ಕೊಳ್ಳಿ, so minus 1 ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, therefore I is equal to n. So if the solute undergo 100% dissociation, the Van der factor is equal to number of particles obtained after dissociation. For example, say example NaCl. So let me take this is undergo 100% dissociation in the water. Water ಅಲ್ಲಿ 100% dissociation ಆಗಿದೆ. What is the Van der factor value ಅಂತ ಕೇಳಿದ್ರೆ, so that is I is equal to 2. So ಯಾಕೆಂದ್ರೆ NaCl dissociate ಆದ ಎಷ್ಟು particles ಬರುತ್ತೆ? There are 2 particles, Na plus and Cl minus. So therefore 100% dissociation ಅಂತ ಹೇಳಿದೀನಿ. 100% dissociation ಆದಾಗ I value is equal to ಏನಾಗುತ್ತೆ? Number of particles after dissociation. Number of particles after dissociation 2 ಇದೆ, therefore I is equal to 2. So let me take one more example. So what is the value of I for KCl? So KCl is electrolyte, definitely undergo dissociation. Therefore I value is equal to I is equal to 2 ಬರುತ್ತೆ. Let me take one more example. Magnesium sulfate. So 100% dissociation again. So magnesium plus 2, sulfate minus 2. How many particles after dissociation? We'll get again I is equal to 2. 2 particles per that. So let me take one more example. Potassium sulfate. What is the I value? That's the last year 1 mark question. What is the I value? First question is ನೋಡಿ. What is the I value for potassium sulfate? Aqueous potassium sulfate ಗೆ I value ಎಷ್ಟು ಅಂತ ಕೇಳಿದ್ರೆ Van't Hoff factor. So ಅದರ ಅರ್ಥ ಏನು ಗೊತ್ತಿಲ್ಲ ಅಂತಂದ್ರೆ you have to assume that is 100% dissociation. So 100% dissociation ಆದಾಗ I value is equal to number of particles. So less particles ಬರುತ್ತೆ K plus and another one is sulfate minus 2. So K ಎಷ್ಟಿದೆ 2 ಇದೆ. So therefore K plus ಅಲ್ಲಿ ಎಷ್ಟಿದೆ 2 particles ಇದೆ. Sulfate 1 particle ಆಗುತ್ತೆ. Therefore I is equal to how much? 3. Last year first question board examination ಅಲ್ಲಿ first question, what is the Van't Hoff factor value for potassium sulfate, that is K2SO4. ಅಲ್ಲಿ ಏನು ಎಷ್ಟು ಪರ್ಸೆಂಟ್ ಡಿಸೋಸಿಯೇಷನ್ ಅಂತ ಕೊಟ್ಟಿಲ್ಲ ಅಂದ್ರೆ you would assume that is 100% dissociation. 100% ಇದ್ದಾಗ I is equal to ಏನಾಗಿರುತ್ತೆ ಎಂದಾಗುತ್ತೆ K2SO4 ಗೆ number of particles ಎಷ್ಟು ಬರುತ್ತೆ 3 ಬರುತ್ತೆ. That is I value is equal to 3. ಅದೇ ರೀತಿ sucrose in the way. Sucrose, what is the I value? I value is equal to 1. Already I said sucrose do not undergo any association or dissociation. Therefore, I value is equal to 1. For urea, again I value is equal to 1. So let me take one more example. Magnesium chloride. What is the I value? If we consider the 100% dissociation, we will get the two particles, that is Mg plus 2 and another one is 2 Cl minus. Magnesium plus 2 ಅಂದ್ರೆ ಬರುತ್ತೆ Cl minus ಕಡೆ ಬರುತ್ತೆ. Again I value is equal to 3. So Van't Hoff factor ಎಷ್ಟು ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾನೆ ಅಂತಂದಾಗ ಸೊ ನೀವು ಅಲ್ಲಿ ಏನು ಪರ್ಸೆಂಟೇಜ್ ಡಿಗ್ರಿ ಆಫ್ ಡಿಸೋಸಿಯೇಷನ್ ಗೊತ್ತಿಲ್ಲ ಅಂತಂದ್ರೆ assume that this is 100%, then I value is equal to ಏನಾಗಿರುತ್ತೆ ನಂಬರ್ ಆಫ್ solute particles ಆಗುತ್ತೆ. ಇನ್ ಕೇಸ್ ಅವನು 80% ಡಿಸೋಸಿಯೇಟ್ ಆಗಿದೆ, 10% ಡಿಸೋಸಿಯೇಟ್ ಆಗಿದೆ, 50% ಡಿಸೋಸಿಯೇಟ್ ಆಗಿದೆ ಅಂದಾಗ ನಾವು ಲೆಟ್ ಮಿ ಯೂಸ್ ದಿಸ್ ಫಾರ್ಮುಲಾ. So 50% dissociate ಆಗಿದೆ ಅಂದ್ರೆ ಆಲ್ಫಾ ಏನಾಗುತ್ತೆ 0.5. 50% ಅಂದ್ರೆ so total number of molecules present is 100, ಅದರ dissociate ಆಗಿದ್ದು 50. 50 by 100 is again 1/2, 0.5. So alpha d ಎಷ್ಟಾಗುತ್ತೆ 0.5 ಆಗುತ್ತೆ. Number of particles ಎಷ್ಟು ಬರುತ್ತೆ ನೋಡ್ಕೊಳ್ಳಿ. That is depends on the solute and we can calculate the I value. If there is no any giving of dissociation, percentage of dissociation, let me take that is a 100%. 100% ಇದ್ದಾಗ I value is equal to n ಆಗಿರುತ್ತೆ. So that is a very important formulas that are very useful for your competitive exams when solving the problems actually. And this is the extra information for your solution chapter. Okay. So some more exams, some more extra information is also there. So that will be explained in the NEET or CET classes. So that's about the solution chapter. ಇಷ್ಟು ಸೊಲ್ಯೂಷನ್ ಚಾಪ್ಟರ್. ಇದರಲ್ಲಿ ಆಲ್ರೆಡಿ ನಾನು ಹೇಳಿದೀನಿ 1 ಮಾರ್ಕ್ ಅಲ್ಲಿ 2 ಕ್ವೆಶ್ಚನ್ ಬರುತ್ತೆ, ಫಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ ಅಂಡ್ ಸೆಕೆಂಡ್ ಕ್ವೆಶ್ಚನ್, ಅಂಡ್ 5 ಮಾರ್ಕ್ ಅಲ್ಲಿ 1 ಕ್ವೆಶ್ಚನ್ ಬರುತ್ತೆ. ಅದರಲ್ಲಿ 3+2 ಅಂತ ಡಿವೈಡ್ ಮಾಡ್ತಾರೆ. ಅದರ 3 ಮಾರ್ಕ್ ಅಲ್ಲಿ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಖಂಡಿತ ಇರುತ್ತೆ. ದಟ್ ಈಸ್ ಆನ್ ಕಾಲಿಗೇಟಿವ್ ಪ್ರಾಪರ್ಟಿ, ಆರ್ ಇಟ್ ಮೇ ಬಿ ರೌಲ್ಸ್ ಲಾ ಆಫ್ ಲಿಕ್ವಿಡ್ ಸೊಲ್ಯೂಷನ್, ಆರ್ ಇಟ್ ಮೇ ಬಿ ಬೇಸ್ಡ್ ಆನ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಟರ್ಮ್ಸ್. ಅಂಡ್ 2 ಮಾರ್ಕ್ ಗೆ ಅಗೈನ್ ಸೊ ಡಿಫರೆನ್ಸಸ್ ಅಥವಾ ರಿವರ್ಸ್ ಆಸ್ಮೋಸಿಸ್, ಐಡಿಯಲ್ ಅಂಡ್ ನಾನ್ ಐಡಿಯಲ್ ಸೊಲ್ಯೂಷನ್, ಅಜಿಯೋಟ್ರೋಪ್ಸ್, ಅಂಡ್ what are the effects of a pressure and temperature on the solubility of gas and liquid. So these are all some questions for 2 marks and also for 1 mark allu ಬೇಕಾದ್ರೆ ಕೇಳಬಹುದು. So that's about the solution chapter. So problems concentration terms ಮೇಲೆ ಆಗಿದೆ already, ಮತ್ತೆ RLUB ಮೇಲೆ ಆಗಿದೆ, that is relative loading of vapor pressure ಮೇಲೆ ಆಗಿದೆ, Raoult's law of liquid solution ಮೇಲೆ ಆಗಿದೆ. And in this session again I will discuss problems on osmotic pressure, and also in the next class there is problems on elevation of boiling point and depression of freezing point. Please open the study material open ಮಾಡ್ಕೊಳ್ಳಿ. ಅದರಲ್ಲಿ problems on osmotic pressure ಅಂತ ಇದೆ. So I think page number 40 41 ಅಲ್ಲಿ ಇರುತ್ತೆ ನೋಡ್ಕೊಳ್ಳಿ. So let me start the problems on osmotic pressure. Okay, first problem, that is 200 cm cube of an aqueous solution of protein contains 1.26 gram of the protein. The osmotic pressure of this solution at 300 Kelvin is found to be 2.57 into 10⁻³ bar. Calculate the molar mass of protein anta ಹೇಳಿದ್ದೀನಿ. So before the solving of this problem, first we have to identify which is the solute here. So in the first question, the solute is protein. Solute is protein. Aqueous solution anta ಹೇಳಿದೆ. So ನೋಡಿ aqueous solution anta ಹೇಳಿದ್ರೆ aqueous solution is nothing but solvent is water. Solvent is water. Now collect the data. 200 cm cube of aqueous solution of protein, that is volume of solution. So volume of solution that is equal to 200 cm cube. I think very good. 200 ml. And again, contains how much of protein? That is 1.26 gram of the protein. What is the protein here? Protein is a solute. How much is given? 1.26 gram. That is mass of solute. That is W2. W is the mass. 2 referred for solute. That is W2 is equal to 1.26 gram. That is the mass of solute. That osmotic pressure of this solution at 300 Kelvin. That is temperature 3T is equal to 300 Kelvin. What is the osmotic pressure? That osmotic pressure pi is equal to, so what is the value given? That is 2.57 into 10 power minus 3 bar. So what you have to calculate? Calculate the molar mass of the protein. So that is molar mass is M2 for solute. That is protein is a solute here. So that we have to calculate M2. So what is the formula? So the formula that is pi is equal to W2 RT into 1000 divided by M2 into V in ml. V in ml or in cm. So what you have to calculate? Our intention is to calculate the molar mass of solute. Therefore, equation solve change ಮಾಡ್ತೀವಿ. M2 is equal. M2 ನ numerator ಗೆ pi ನ denominator ತಗೊಳ್ಳಿ. W2 into R into T into 1000 divided by, so M2 is considering pi ತಗೊಳ್ಳಿ into V in ml. In CM2. Substitute the value. W2 is equal to 1.26 R value. So R value ಕೊಡಬೇಕಿತ್ತು actually. So don't worry. R value ಕೊಟ್ಟಿರುತ್ತಾರೆ. So ಇಲ್ಲಿ R value ಏನಾಗಿದೆ observe ಮಾಡಿ. So pi is in bar. ನಾನು ಆಗಲೇ ಹೇಳಿದ್ದೀನಿ ನಿಮಗೆ osmotic pressure ಮಾಡಬೇಕಾದ್ರೆ so R value input ಇರುತ್ತದೆ ಅದರ ಬೇಸ್ ಮೇಲೆ pi ಯೂನಿಟ್ ಬರ್ತಾ ಇರುತ್ತೆ ಅಂತ. So ಇಲ್ಲಿ ಬಾರ್ ಅಲ್ಲಿ ಇದೆ ಅಂತಂದ್ರೆ R value is equal to 0.083 liter per mole per Kelvin. ಅದೇ ನಿಮಗೆ ಏನಾದ್ರು ಅಟ್ಮಾಸ್ಫಿಯರ್ ಇತ್ತು ಅಂತಂದ್ರೆ 0.0821 liter atmosphere per mole per Kelvin ಆಗುತ್ತೆ. So the value 0.083 into what is the temperature value? That is 300 into 1000 whole divided by, what is the pi value given? So pi value is 2.57 into 10 power minus 3. So and then volume is 200 cm. So calculation ಮಾಡ್ಕೊಂಡ್ರೆ so here the denominator numerator, so here ಮಾಡ್ತೀವಿ so put numerator ನ multiply ಮಾಡ್ಕೊಂಡ್ರೆ so we'll get so 31374 into 10 power minus ನ ಮೇಲೆ ತಗೊಳ್ಳಾಗುತ್ತೆ 10 power plus 3 ಆಗುತ್ತೆ divided by ನೋಡ್ಕೊಂಡಿದ್ದು 2.57 into 200 ತಿಳ್ಕೊಂಡಿದೆ so 2.57 into 200 is 514. so ಎರಡನ್ನು multiply ಮಾಡ್ಕೊಂಡ್ರೆ so divide ಮಾಡ್ಕೊಂಡ್ರೆ ಉಳಿಗೆ 61.0389 into 10 power 3. So you 10 power 3 na. So 1000 ಇಂದ multiply ಮಾಡ್ಕೊಳ್ಳೋಣ. So ಒಳಗಡೆ multiply ಮಾಡ್ಕೊಂಡ್ರೆ 61,038.9. That is the molar mass of solute. What is the unit for molar mass of solute? That is gram per. So this is the 3 marks problem. So equation pi is equal to W2 RT into 1000. Divided by M2 into VML. So in the given problem, you have to calculate molar mass of solute. So the equation rearrange ಮಾಡ್ಕೊಳ್ಳಿ. Substitute the values here. So finally we get the molar mass of solute about the 61,038.9 gram per molar. Sir, ಇಷ್ಟೊಂದು ಬರುತ್ತಾ ಅಂದ್ರೆ so just remember solute here. Solute is a protein. Protein is a polymer. Polymer ಗೆ molar mass ಏನಾಗಿರುತ್ತೆ ಜಾಸ್ತಿ ಇರುತ್ತೆ. So that is about 61,000 ಎಷ್ಟು ಬಂದಿದೆ 61,038.9 gram per molar. Approximately 61,039 ಅಂತ ಬರೀಬಹುದು ಯಾಕಂದ್ರೆ 9 ಇದೆ so approximately 8 ನ round off ಮಾಡಬಹುದು 9 ಅಂತ ಹೇಳಿ. So that's about the first problem. Okay, move to the next problem. Calculate the osmotic pressure in pascals exerted by a solution prepared by dissolving 1 gram of polymer of molar mass 1,85,000 in 450 ml of water at 37 degrees Celsius. Now, so there is the R value 8.314 into 10 power 3 Pascal liter per Kelvin per mole. So let's collect the data for the second problem. Second problem, data. Calculate the osmotic pressure in Pascal. That is, you have to calculate by Pascal. So Pascal R value Pascal. Pascal. So again, by solution prepared by dissolve 1 gram of polymer. This is a solute here. Solute is polymer. Solvent that is water. Solvent is water. So what is the mass of solute? That is the mass of polymer 1 gram. That is WO2. Mass of solute is equal to 1 gram. Molar mass that is molar mass of polymer. That is solute. M2 is equal to 1,85,000. That is gram per mole is the molar mass unit. In 450 ml of water, there is a volume that is equal to 450 ml. So at 37 degrees Celsius, temperature is equal to 37 degrees Celsius. That is equal to 37 plus temperature substitute by Kelvin plus 273. That is equal to how much? We get 310 Kelvin. That is the temperature. So that is R value is given. That is R is equal to 8.314 into 10 power 3 Pascal liter per Kelvin per mole. So now we have to calculate pi value. Parity equation. So pi is equal to WO2 into R into T into 1000 whole divided by M2 into V in ml. Okay. So then what is the value of WO2? That is 1 gram. Then what is the R value? That is 8.314 into 10 power 3 into. So what is the temperature? That is 310. Then again 1000 whole divided by molar mass of solute 1,85,000. 1,85,000 anna 185 into 10 power 3 gram per mole anta ಬರೆಯಬಹುದಾ? 185 300 that is into 10 power 3 nothing but 1000. So that is into 10 power 3. What is the volume? So volume is equal to 450 ml. So again here 10 power 3 gets cancelled. So again ಮಾಡ್ಕೊಳ್ಳಿ ಅಂದ್ರೆ 8.314 ಗೆ 1000 multiply ಮಾಡಿದ್ರೆ so we will get 8314. So again point of 3.3 ಇದೆ 1000 multiply ಮಾಡಿದೀನಿ into ಏನಾಗುತ್ತೆ 310 divided by 185 into 450. So calculate ಮಾಡ್ಕೊಳ್ಳಿ ಅದು that is 8314 into 310 divided by 185 into 40. So that is equal to 30.95. So what is the unit of pi now? So pi unit ಬರಿಬೇಕಾದ್ರೆ r ಅಲ್ಲಿ ಏನು ಯೂನಿಟ್ r ಯೂನಿಟ್ ಏನಿದೆ ಅಲ್ಲಿ ಪ್ಯಾಸ್ಕಲ್ ಇದೆ. So therefore 30.95 ಪ್ಯಾಸ್ಕಲ್. ಇದನ್ನ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ ಎಷ್ಟು ಬರೀಬಹುದು 30.9 so 959 ಬರುತ್ತೆ 30.96 ಪ್ಯಾಸ್ಕಲ್. That is the pi value. So there is the osmotic pressure. So in the given problem, so that the data W2 is the mass of molar, that is polymer is the solute and solvent is water. So molar mass ಕೊಟ್ಟಿದ್ದಾನೆ, volume ಕೊಟ್ಟಿದ್ದಾನೆ, temperature should be in Kelvin, convert ಮಾಡ್ಕೊಳ್ಳಿ, R value ಕೊಟ್ಟಿದ್ದಾನೆ. So then calculate the pi value. That is 30.95 959 Pascal ಬರುತ್ತೆ. So ಇಲ್ಲಿ 5 or 9 ಇರೋದ್ರಿಂದ 5 ನ ರೌಂಡ್ ಆಫ್ ಮಾಡ್ಕೊಳ್ಳಿ 6 ಆಗುತ್ತೆ 30.96 Pascal ಆಗುತ್ತೆ. So that's about the problem number 2 and remaining problems ಇನ್ನು 7 problems ಇದೆ. So that will continue in the next class. Thank you.